Alright guys, we're back with another video here for this isometric game that we're making, hopefully an RPG. Uh, it's been a little while since I've done a video, been busy with some life stuff. Today I want to make a comeback video where I'm going to do something fun. Last time we talked about this float delta variable. It's the time between frames and you can use it to lock player movement. In this example we used it that the player can only move every 1 second, right? Now we're going to do something even more fun with this. We're going to use it to generate the map, and we're also going to set something up for the future that's going to make our game a little bit more efficient in terms of, a little bit less heavy. You always want to look for efficiency with games because there's going to be so much going on every frame to render and update and stuff. Any place you can cut out some of that, you want to. So right now, every single frame, 60 frames per second, we're running through this double loop. Now, computers are incredibly fast, but if you can help them out a little bit and simplify things, that's good. We're running through this loop, and we're doing this math, and then we're rendering stuff. What we ideally want to do is just render though, right? Like just render the ground tiles and have this math all done ahead of time. And I'm going to set up sort of how to do that today. Now, I'm not actually going to finish it today because today what I want to focus on is actually doing something just kind of fun. And then later, probably next video, we'll fix it up to be the actual working version because what we're going to do today, I'm not actually sure what you would use it for in an RPG game, though I bet there are uses because it's pretty cool. So like I said, we're going to be messing with this delta variable. So we're going to, just like in our player thing, we're going to private float, if I can ever spell float correctly, and we're going to make a time variable. Private, we're also going to need, okay, so we do need this time variable. And just like last time, we're going to need the delta variable coming from the main render loop. And as you remember from the other times, our main render loop is right here. And it passes, right now, just the sprite batch into this. But we also wanted to pass the time between the frames, this delta variable. So there you go. It's going to pass it in. And then we'll be able to use it, right? So just like in the player thing, time plus equals delta. Cool. Now, and just like in the player thing, we're going to set up an if here. And we're gonna do something pretty fast. We're going to say if time is greater than 0.3 or something. So that's only a third of a second, right? Whereas for our player, it was every 1 second, which I'll probably change this later because that's way too slow for movement. But every third of a second, we want to generate a piece of our map, right? So we could just take this code and put it in here, and oh, it's going to magically render our map, right? Well, it's not. It's going to do some pretty much nothing because, whoops, I forgot to set time back to 0. Okay, so at the end you have to set time to 0, but right now there's going to be no persistence, right? It is going to render our map every third of a second, but nothing else is going to happen. What we want is for it to render our map block by block and then for it to persist afterwards. Now, how are we going to do that? Well, I made this ground class here. Now, this is a very simple class. I don't think it requires much explanation. You have a constructor which takes in an x and a y which represent the location of this particular part of this particular tile, basically. So one of these little tiles here that you can see flashing on the screen. So, and then you have the texture, which we've just called grass, and then you can get the x location, the y location, and the texture. Now, this is no different than what we're doing here, where we pass in grass, x, y, tile width, tile height. We'll do this again, but there's no need to put it in this class because we have it as constants in any case. But instead of drawing it directly like this, we're going to be adding these to a list. And then instead of looping through doing a double loop every frame, we'll only be doing a single loop, which will just render all the grass that we've already pre-added. So we obviously don't want this loop here, right? Also, you might want to keep your files a copy of the files the way they were before we make these changes, just in case next time I decide that it's a little bit easier to work off that base than this one. But I think it'll be fine. So cool. Control Shift F. So how are we going to do this? How are we going to make it render block by block at a time and then persist? Well, we still have to have column and row, right? Because we still have to have this X and Y. So we're just going to go up here and we're going to make, actually these can be ints. Column. Okay, so now we don't have any compiler errors, but our math is still not quite right because we need to do the work of the loop, but without a loop. How are we going to do that? Well, we still have to decrement the column, right? Because we have to get through each column. We have to get through each row too. The rows, we can't decrement them every time because, you know, the way a double loop works, right, is that it's like you have the row and then you go down the column, row, right, and then you have to reset column and row. So, well, first off, if the row is less than 0, we want to do something. We know that because we don't want an index out of bounds exception. Once we're down to the bottom of the array, just like in the double loop last time, just like normal looping, you don't want to go below 0. You want the loop to end at that point. Same thing with column. We don't want to go into negative indexes, get an exception. Cool. What do we want to do? Actually, let's do column first because column is simpler. All we want to do is set column to its default value, which is map.length -1. That's no different than what we did in the loop. If you'll remember in the loop, it was just column was initially set to map.length -1, and so was row, because this is a square array, so we don't need to differentiate between the two. They're both just map.length -1. And that's so that we don't, you know, get nasty array index out of bounds exceptions or whatever. Cool. Anyways, so we need to set this back to its default value, which we know is just this. Once, in that way, we can start looping down the next column or go down the next column. Now, the row is interesting because when we've reached the final row, we're actually done. So we don't really want to reset it to its default value. We're going to, right at the moment, I kind of rigged this up quick the other day, so this code's is a little bit just kind of jammed in here. We're going to partition this out a little bit later, maybe to make it look a little bit better. Like I said, this actually isn't going to be in this draw ground loop. This code is eventually going to be moved a little bit. Anyways, cool. So this is the basics of it, except we still don't have persistence. What do I mean by persistence? Well, right now, just like you saw that flashing map, it's going to draw this grass tile at the correct location, but then a third of a second later, it's going to draw a different grass tile, and there's going to be no persistence. It's not going to keep drawing this grass tile. So what we want is an array of these ground objects, right? And then we're going to use an array list in this case. We could use a regular array, but I'm of the opinion that anytime you can use a list, it's probably just better to. I think lists are basically superior in every way. And an array list will do fine in this situation. We're not planning on adding or deleting from it or anything like that. Or we're not planning on, deleting from it or anything like that. It's not going to have to be dynamically resized or anything. It's just going to be a static thing. Once it's created, once everything's added to it, it's just going to be rendered every frame. So an array list will do just fine. We do not want the parentheses there. We're going to just call this the ground because the array list will collectively be the ground. Ground, new. And if anything here is like kind of confusing to you, or maybe I do something stupid and you're like, wow, that's just like the least efficient way you could have done that, let me know in the comments. Totally fine. Like I said at the beginning of this project, we're really just trying to have some fun with this. And I think through the course of this series, I'm going to show off lots of fun stuff. And today is one of the sort of fun things so that you can do with this delta variable. And you can really do a lot of stuff with this delta variable. Being in games, being able to cap things to only happen at certain time intervals is a big deal. A lot of games use this where they only do things once every half second, once every 5 seconds, or something like that. Or you could even use delta to do something just once, right? You could say, like, if the player presses this button, you could have this delta thing start adding up, and then after it becomes 5, do something. So this is the concept here. If you can get it, you can use this in so many ways. This whole being able to do something after a certain set amount of time, whatever that time interval may be. Cool. So we have our list now. So instead of doing this, what we're actually going to do is we're going to say ground.add. And then we're going to add, let's see here. I'm going to add, what was our ground thing? Okay, it's XY texture. So we're still using this XY, just like I told you, nothing has changed. And then grass. Boom. That's it. Oh, wait. I'm dumb. That's the part I was missing. New ground. There you go. That's it. We have to actually use the class we created and not be dumb, but cool. Anyways, that's it. You just add it to it. Now, we go down here. I'm going to say we're going to use a for each loop to loop through this. So ground G and ground. So for every ground object in this ground array, boom, get its texture, get its x position on a coordinate plane, of course. I assume anybody watching this video probably knows the basics of like coordinate planes. When I say x and y, I'm talking about like xy on the screen, basically, or in the game world. Just a really basic 2D coordinate plane. Now we have persistence, because as the tiles come in, they're being added to a list, and that list is going to be drawn every frame. Now, what we I know what you're thinking to yourself, well, won't it just add ground infinitely? And yes, it would. We're probably going to need some sort of Boolean value, so this only runs once, right? And ideally, you would do this probably when you created the map. You would also just do the math for this all together, so that way it's done in the constructor. Boom, when the game loads, it's already ready, and you could actually, and then, like I said, this would become a very simple render loop, right? Because this is the only thing that would exist in it magically. Unless you wanted to do what we're about to do, which is render the map block by block. Don't know if it'll have a use in this game or if it has a use in your game, whatever game you're trying to make. But it is pretty cool. It's going to be pretty cool. So we're probably going to have to create some kind of Boolean here. Let's just, I don't know if this is the best way to do it, but it's the first way that comes to mind. You can name it whatever you want. Let's put it here. We want it to be false initially. So if we're not done, if done is false. I was thinking of two things at once there. That's why I wrote false. But anyways, then we want to do this. I think we always want to do this, right? Yeah. Does this work? Are we done? Oh, no, we got to set done to true at some point. Once we've gone through all the rows, we probably actually don't even need this. But I'm going to leave it there for now. We can optimize this later maybe. Like I said, today I'm just showing something kind of fun. We probably don't need this. Yeah, let's just see what happens. This is pretty fast. Oh, look at that. It's kind of cool, huh? Oh, what's going wrong with our XYs? What did I mess up here? Oh, we are not decrementing our rows. How did y'all let me forget that? Come on now. Anyways, we're not moving on to the next row. Okay, so when we're done with our column, we want to go to the next row, right? So we have to decrement it. I was like, what the heck? Anyways, now it should work just fine. We're going to build our map in real time. Like I said, this seems like a pretty cool feature to me. I don't know if y'all can find a use for it. I really don't know if there's a use for it in this game. You could probably create some kind of cool game where the map sort of builds itself or deletes itself. You could actually have the map delete itself and the player has to run away from it or something like that. And of course our player movement still works. You know, every 1 second we get to move or whatever. We haven't constrained the player to the map or anything yet. And of course our map size is still random. I don't know if long term that's going to be good either, but you know, I hope you get something out of this. I think we're going to call that a video for today. Now, the reason why this sort of ground thing is important is because, like I said, we want to simplify this render loop as much as possible because we have to do it 60 times per frame, right? And we want to be as easy on the computer performance as possible with the game, even if it is a simple 2D game. Let's see if once we get to the end here, there's any like weird, hopefully it doesn't like bug out on us, you know? This is a rather big map. It randomly generated us a kind of big one. Oh, we did get, where was, okay. It must have decremented one too many times. Maybe we need to check the row after the column. Let's make this like really fast. Hope for a small map so we can test this. Oh yeah, that's so fast. Ah, there we go. Okay, now it doesn't throw an exception. All right. And like I said, if you wanted to do this another way you could delete from the map, we could also just apply this and we could say, you know what, we're going to create this list of ground at the beginning, and then all we need to loop through every frame is one loop, not two. We're literally, we're cutting it in half there, increasing performance. And we'll do something like that coming up. I just wanted to show you all this. I thought it was a fun coming back video. For this doesn't even have to be used in an isometric game. You could apply this to like a lot of things. And like I said, this delta variable, locking stuff to time intervals or doing something after a certain amount of time, massively useful in games. Player does something, 5 seconds later something needs to happen, boom, you can use delta for that. Like I said, massively useful in games. I think what we're going to start doing is we have our map here, right? This is like one layer. I think we're going to start doing like an item collection system. I'm a little bit hype on that. I was thinking about doing a dialogue system, but I think I'm hype on the inventory. So we have this map here, we have this map layer, and that represents our ground, but maybe we want another layer that represents items, right? And then we want our player to have access to these layers, right? So whenever he moves, we can create some sort of method that will check what he's moved onto. Check the item map, right? Did the player hit an item when he moved? Is the player next to an item? Is the player hitting ground? Is he hitting air? Does he need to die for what he's done? Has he hit an enemy? Something like that. Anyways, we'll have these different map layers that our player is going to check into to see what's next to him, what he's doing. This will be useful in all kinds of systems, whether he's picking up items, interacting with enemies, all that kind of good stuff. And I think we're also going to work with some enumerations. You know what? Maybe I want to put this in another file because it's going to be, if you've never used an enumeration, they're massively useful. Interactables, we'll call it interactables for now. They're massively useful because what we're going to do is we're actually going to create a list of interactables. And it's just, this isn't really necessary. We could do ints and we could say like, okay, a coin is 3, a sword is 4, you know, a big sword is 5. We could do that with ints, but this is going to be so, using enumerations and coding makes it so much more clear, because you could say something like this, for example. You could say coin, and then you could say, you know, sword. And then when you're in your player, to make sense of your code, you know, you can say like, okay, if at position 0, 1, the sort of item or equals, you know, item, you know, interactables, and you could, I don't know if it's going to let me because of the way this is all screwed up, but, you know, if it equals interactables.sword, do something. You could just say if it equals 1, right? But that's not very descriptive, and I think that like writing some descriptive code is usually good. So we'll put some stuff, if you don't know anything about enumerations, they're really easy to use, but they make code like massively more readable, which is a good thing. And anyways, that's not the point of this video. I promise I'll explain it a little bit better next time. And this one will be like, you know, we'll create an enumeration for map objects or something, which will be essentially different types of ground objects. So the ground, hole, whatever we want. But we will do that next time. I think we're going to get straight into some type of like item system next time. Anyways, don't let me rant forever. It's already about 23 minutes on this video here. I'll see you guys next time. Hopefully you got some cool use out of this. I think this is really cool. Like I said, see you next time.